So today we'll be doing addition of two 8-bit numbers. So for that, first of all, just open a file inside 8086 folder. Okay. So add.asm. So first of all, we need to write the data segment and the code segment. Okay, after writing this, we have to uh, declare the start. Or before that, we have to write the assembly directive, which is cs assume code and ds data. Then start move data into x, then move to x. Then we have to stop it. For stopping, we have to move 4C00H into AX. So 4C00H, and then we have to call the DOS interrupt, which is basically 21H. Okay, and then we have to end the start. So end start. So this is the basic code. Now just let's write a program to print. So we'll make a procedure. So for making a procedure, we have to write like procedure name and proc and procedure name and entp, and in between this we have to write the procedure. So we also need to include return, because the procedure has to return to the main program. So for printing, first I'm assuming, I will just write it here, assuming I have to print content in AL register. So I'll first move content in AL into DL. Then for printing, I have a function. So to call that function, I have to I think I have to enter 10 into 02 into H register and call interrupt. Okay, so this is the print function which prints the content in AL. Now let's write the input function. So similar input proc, and then input np. Between it, write the return function, return. Okay, so for inputting, we have a function to input a character. So which is we have to move 01 to AL register. So 01 into AL register and call interrupt 21H. So this will input a character which will be stored inside AL. So this will input the char, store it in AL. Okay, let's test this code first of all. So I will write the main program here. Okay. So first I will just call input. Okay, after calling input, I will print it. So call print. But in between this, when I call the input, okay, yeah, I think this will be fine. Let's test it. I will open the DOSBOX. and then maths and the file name, and there is no need to write the file name .asm. You can directly write the file name only. Link add. Okay, no error found. Okay, if I import 9, I get 9. If I import k, I get k. Basically, I'm just inputting a number and then displaying it. Okay, now we have to import 4 digits. If you see, 8-bit number can contain up to 2 digits. So in 2 digits, for that I have to input 4 characters. So let's edit this function. So instead of storing 1 character now, I will store all 2 numbers, basically the 4 digits. So for that, after I get it from AL register, I have to store it to a temporary register. Let it be BL, BH, CL, CH. So I will just move this into BL first. Similarly, I have to do it for 4 characters. I'll just copy this. Okay, first I move to BL, then let's move on to BH, then CL, then CH. Okay, so now the number is inside, the characters are inside BL, BH, CH. Now, if you see, for example, I write 21, we will get it 2 inside BL, 1 inside BH. But you have to make it 21, right? For that, I will multiply the upper digit, which is BL, into 10 and plus BH. Similarly with CL and CH, CL into 10 plus CH. So code BH BL multiplied by 10 plus BH. That's what we are going to do. For that, I will just move 10 into A, and I will just say multiply BH BL. So AL has 10. So for multiplying, one number should be in A, and we can say multiply with this register. So mul BL. So we'll get the answer inside AL itself. So I can just move. I will basically, here what is going to happen is BL has, if the number is 2, the BL has 2. After doing mul BL, AL will contain 20. So I'm moving this 20 into BL again. Okay, after moving this, I will add that 1, which is basically 21, I said. So 1 is in BH. So I'll add BH in BL. So 20 plus 21. Yeah. Similarly, I will do it for the CL and CH. So I'll just copy this. Okay, I'll copy this and paste it here. Just that it's for CL now. Okay, now what's the conclusion? Now we have numbers in BL and CL. So now we basically have the numbers in BL and CL. Now what we have to do is, after we call the input, we have to add them, right? So add BL, CL. What this will do is, will basically add the 2 numbers and store it in BL. Okay, I'll just write it here, adding two numbers and storing in BL. So now BL has the number, we just have to print it. But while printing, there's one thing we should remember. First of all, what we are inputting is we are inputting it as a character. So after inputting as character, we will have to actually change it into like numbers. For that, here we need to make an edit, which is basically we have to convert it back to numbers. From ASCII we have to convert into decimal. For doing that, we have to subtract 48 from each register. So subtract BL comma okay BH CL CH. Hope you understand it, because as we are not doing the multiplication operation on the ASCII value, but we have to get it into decimal. So for that we have to subtract 48. So after that, after subtracting 40 from each register, we basically get the decimal value. After that, we do these functions. Okay, so after getting this also, now I have stored the result into BL register. But if for example BL register has 100, so we can't directly say like print BL after passing into AL using this print function. We can't do that. Why? Because 100 is a 3-digit number, but it will only print one character. So basically the 100 needs to be converted into 3 digits. So basically the digit for 0, 0 and 1. So basically what we have to do is we have to get the digits of the BL. So I will just explain it here. So we need to get the digits of BL. So if it's 255, we have to get 2, then 5, then 5. Then we have to print individually 2, then we have to print 5, then we have to print 5. Okay, so let's make a procedure called display. So display rock display np, so make a return. So the logic we are going to use is, first of all we take the number. So the number is in BL, already know. Then we are going to compare it with an 9, because if it's greater than 9, it's of course not a decimal value, it can be anything like character. So if it's greater than 9, we'll divide it. Let me show you how it works. Okay, I will show you in the notebook. I will write it down and show you. So basically, if there is a number like 805, so this is stored inside BL. What I have to do is I have to get the individual digits, so I can display it using the print function. So for that, first I have to do is I can divide it by 10. So if I divide by 10, I get 80 as a remainder, 80 as quotient, 5 as remainder. So I get 5 from here. After that, what I will do is I will take this 80 and divide it by 10. So 80 divided by 10, I will get 8 as the quotient, this 0 as the remainder. So see, I get 5, 0, 8. So using this method, I will be doing it in the program. Okay, so compare. First of all, I have to move B10 into BH, then move. Then I have to compare this. Compare. No, 10. Sorry, 9. 9 into BH, and compare the BL, BH comma BL. So using compare, if BL is greater than BH, which means if my number is greater than 9, then only the carry flag will be set. So which means if number is greater than BH, I have to display more than one number. So jump on, let's say a label, jump on a label 2. 2 basically I mean is it's more than 1, let it be 2. Okay, so if it's not 2, then it's of course 1, right? Oh, not more than 1, then it's of course one digit is it's lower than 9. So it's, which basically means BL has a number which is lower than 9, so we can display it directly. So if we can display it directly, we'll just move BL into AL. Then for displaying, we have to again add 48. First we subtracted 48, now we have to add 48. Add 48. All print. After calling print, we have to jump to the end of display. So JMP end. Now why? Where is end? End is here. Basically the end of this function. Okay. Now if it's not one digit and it's more than 2 while comparing, then we have to divide by 10. So for example, if it's 15, we divide by 10, so remainder is 5 and quotient is 1. So we basically get the digits. That's how we do it. Okay, so let's say move 10 to BH, move BL into AL. So for division, our number should be in AL, and we can divide it by like div BH, which basically divides the number in AL, which is our number. If it's 21 is inside AL, then we divide it by BH, which is 10. So it's basically 21 divided by 10. Okay. Now the answer is stored inside AL and AH. So AL has the quotient, AH has the remainder. So first we'll move it into BL and BH. Move AL, move BH. Okay. Now it can be 1 or 2 or 3 or etc. It can be more than 1, right? So here we can write a recursive call. For example, if consider this as 193. So first it will do is check if it's greater than 9. Yes, it's greater than 9. Then it will move to this label. After moving to this label, it will divide it by 100. So it's basically 3 will be stored inside AH and 119 will be stored in AL. So but 19 is again a 2-digit number. So for that we'll call this function again. So basically like recursion. So call display again. So this will do the trick because our number is in BL and this function deals with the number in BL itself. So 19 is inside BL, so it will go again to the 2 and then it will separate 9 and 1. So we'll basically get individual numbers 1, 9 and 3. Okay, call display. Now we have to display the remainder. So for that move AL comma BH and um, add AL comma 48, then call print. So yeah, now one thing you have to keep in mind is when I call the display again, this BH will change here. So if BH change, for example, I call 193, after calling this display 199 will be there, but the BH will change. The BH for this display will be around 9 itself, but the BH which was stored for 3 will be erased. So no, so for that, so we need to remember the previous BH. So one method is we can store it in CL, like move CL BH, and then we can call it here to move BH comma CL. This is one method, but a better method is we can store the value of B register inside the stack. So we'll just push BX and pop BX. What it does is it pushes the BX before going to the procedure, and after procedure is complete, it pops the value into BX. So basically we're getting the value of BX back. Okay, so yeah, this is the function. Now let's test it. There's a DOSBOX. Okay, so massum add. Okay, we have a warning error. Reserve word use a symbol. Okay, so end is a reserved word. Let's make it end with 2D. Let's make it okay. Okay, no errors now. Now say link add. Okay, add dot. See, let's do like 90 plus 80. It's showing P, so we have made mistake somewhere. Let's try one more. 01 01. Okay, it's not printing now. Okay, so I think the error is with printing. Figured out the error. So the error was basically I didn't call the function itself. I called print again, so I had to call display. So let's save it and run it again. So massum add link add dot x. So let's do this. Okay, so it's working. 90 plus 70 180. Let's try one more. One digit 1 0 0 5 0 9. Yeah. So that's how you do addition. Okay, so see you on next video. Bye bye.